So welcome to the lecture on IT operations and networks. By no means am I going to make you a service desk analyst or a network engineer in this lecture. That is not the intent, but hopefully give you some very high level information and a review of some of the reading material that you had and put it into real life situations. So the objectives of this lecture are to identify the collection, storage, and retrieval devices, describe networking, describe the components of a network, and describe the connection and communication that happens on a network. So just for review, we've got EMR versus EHR. So an EMR is owned by the organization or the doctor's office, the hospital. It's that medical record that belongs to that organization that they're responsible for maintaining and keeping secure, the electronic medical record. The electronic health record is the total health of the person. It could come from many different areas. It could come from vaccinations at the health department to an annual exam at their doctor's office to an emergency ED or ER visit. And so it's all of that different medical information that's shared across all these different organizations to have total care of the patient or continuity of care of the patient. And so in order to have an EMR or an EHR and have the data collected, stored, secured, be able to be retrieved, and then shared, we need to set up devices to collect it, devices and things to store it with, and a way to transfer that data securely and efficiently across many places. So again, the collection, classification, storage, retrieval, and dissemination of recorded knowledge. And we need to configure devices and networks in order to be able to do this. So we need input devices. These would be your computers, vital sign monitors, EKG machines, imaging devices, which could be document scanners. They could be cameras or digital imaging devices that's used in diagnostic imaging or X-ray radiology. Could be lab analyzers, all different ways of getting information in, that data into a system. Then we need to be able to store that. So you hear about storing things out on servers. The hard drive of your computer is a way to do that. But we have optical storage, SD cards, CDs, servers. We've got the cloud. These are all areas and places to store data. Once we get it into the device, we need to be able to retrieve that information and then send it somewhere else. And we do this through various languages and through transfer protocols. Then we need to be output. So after we've retrieved it, we need to be able to send it somewhere, whether that's a fax machine, a printer, display it somewhere else on another person's monitor, in another application that they use, which again can be done with languages and protocols. So when we talk about configuring devices, I like to start with, if you remember, our workflow. And when we talked in the lectures about workflow, a little bit about ergonomics, and we showed some of those pictures of where the challenge of health information technology starts with that user and figuring out what the needs are. Then we have to figure out how we're going to power these devices. And by power, it's not just plugging it into the wall. It's, does it have enough power source? Is it plugged into a generator outlet? In health IT, it's very important. You can't have a person in surgery and have them cut open and not breathing and asleep and have the power go out. You have to have your devices plugged into alternative power sources or backup generator sources. And you need to consider if those devices need to have a UPS attached to them or an uninterrupted power supply. And in my world, we have EEG machines that are set up that way because they're mobile devices. The actual cart that rolls in the encephalogram machine into a patient's room has its own uninterrupted power supply or UPS. It has a 4-minute battery backup because it takes 2 to 4 minutes for the generators to kick on. So even though the device is technically plugged into the wall, into a red generator outlet, When you're recording somebody's brain waves, you can't have a moment's gap because you're trying to look for seizures and odd activity. So we have it on a UPS so that it gives it that 4-minute to 8-minute window before of power, uninterrupted power before the generators kick on. So then you need to consider what kind of hardware, and this goes back to ergonomics and what the end user needs. Is it a mobile device? Are they on the go and need something more like an iPad or a smartphone? Do they need to have Bluetooth technology because they're dictating and need to have a certain kind of headset on versus a handheld mic? Is it a large monitor? Maybe it's a 24-inch widescreen monitor versus a 17-inch square monitor. Maybe it is the location of where that hardware is going to go, and you couldn't put a big bulky terminal up on the wall the way you can the flat panels. Does that hardware need to be on a cart? Does it need to be more mobile than if it was hard mounted on the wall? And if it is mounted on the wall, does it need to be able to be moved and angulated so that you can work and face the patient or turn around and do different things while you're accessing the patient? We talk about barcode med administration and being able to use a barcode scanner. That scanner has to have a particular ergonomic feel to it. Do you have more of a gun model that has like a trigger pull and is, like a gun shape with a handle and a muzzle, or do you have something that's more like a remote control device, a TV remote control device that's smaller and fits in your pocket or can snap easily onto a belt and be carried with you? Is it wired or tethered, this barcode med administration scanner, or is it not tethered? Due to workflow considerations, is it reasonable to have the staff have a 25-foot tethered cord that can expand in order to reach over the patient to actually get to the patient when the wall-mounted computer is farther away? Infection control. Do you really want a barcode med admin device to be mobile and go from room to room to room for a patient versus a standalone monitor and computer system that's mounted on the wall so that the germs don't get spread from room to room? A lot of things to think about when it comes to hardware. Then we have firmware. And so when we talk about configuring devices, and we'll get into this with troubleshooting, but firmware, for lack of a better term, to keep it simple, is the software that's specific to that device. So if you think about your computer having a motherboard and a hard drive and a network card, then you've got the software or the application software. You get your operating system like Windows 7 or Windows 8. You get your application software like the Cerner EMR at Community or the Epic EMR, which is a type of software. Microsoft Office is a software application. So the operating system could almost be like a type of firmware. I think of our Access Print Doc servers that we have. It's a little hardware device that sits on a desktop. So the computer itself has print and scanner software that you install on the actual computer, and then that has the drivers for the printing device, but then the actual device itself can get updated, or a firmware package that can actually configure the electronic components of the device itself. And if it doesn't have the latest firmware, sometimes it won't work with certain applications. So there's kind of two components there. We talked a little bit about software. And then you have naming the device. So when you're configuring your devices, you have to decide what kind of name you want to give them. And usually there's a common name, like my computer's name is IT Carry, but it also has an IP address, which is 10.131.25. something, right? And that's the IP address. And those two need to work in conjunction with each other when we configure them out on the domain naming service, or out on the DNS, because if those two differ in some way, you can't use the other applications, like our remote desktop applications. We can't find that device won't function properly. And finally, we need to be able to connect to a network, and that connection can happen through cables, it can happen wirelessly, and then once we get it physically connected, whether wireless or cabled, we need to get it to communicate to the network. So troubleshooting the devices itself, if we think of the desktop computing that was in the various reading, we always joke, is it on and is it plugged in? And seriously, number one questions in service desk, is it on and is it plugged in? The next thing is the type of hardware. What is it about it? Does the mouse actually work? If it's a wireless mouse, does the battery need replaced? Is the optical eye on the mouse open? Some of the mice have a window that will cover that optical communication piece so that you don't wear out the battery. So is that on? Is the wireless keyboard or the mouse actually on? Some of them have switches. Some of them have a connect button. Is the cabling bad or kinked? You may have a mouse that's hardwired or tethered to the computer, plugged in, but it's had so many kinks in it. Either the wires are kinked right now because there's something pinching it, or the wires have worn out inside or been damaged because it's been kinked too many times or overused. Buttons wear out. Keys, the paint wears off on the keyboards. The actual physical device, maybe it can't have a firmware upgrade any longer, or maybe there's no longer a driver that can be installed to make that work. And so it could be useless, so that might be one of the reasons it's not functioning. We talked a little bit about the firmware. Software applications. I have issues right now where I'm using Microsoft Office 2010. I got on a computer somewhere else in the hospital because I didn't take my laptop with me to a meeting, but because I'm on a network and I have a file share, I have access to all of my documentation out on the servers that I can access from any computer that's on our network. So I log onto the network, pull up my OneNote notebook so I can take meeting minutes in Microsoft Office, and the computers at the hospital had 2007 Microsoft Office on them, not 2010, and I couldn't open my notebook. So is software the issue? Adobe Acrobat is a problem that I've come across a lot of times. The Adobe Reader, if it's not updated, the different documents that come across that you might pull down from the internet or that have been scanned won't open properly. If your computer doesn't have the right Java on it, or it has security settings in the Internet Explorer settings or Internet option settings, you can't view certain things, you can't get to certain websites, or certain types of other screens won't open when you're on the internet, or certain I hate to say documents, but other web pages or pop-up windows may not open properly or display properly because you don't have the internet options configured properly. We talked about naming the device, and I talked to you a little bit about troubleshooting. We've got, we're getting into this a little bit about naming the devices, and if the IP address isn't correct or it's not associated properly on the DNS, we have this issue at Community because I have two different DNSs because we have an area across town and we have naming problems. Sometimes I can't get to the remote desktop because the name of the computer I'm looking for doesn't recognize the IP that's associated with that name, and vice versa. We configure them out on an OU. So the OU is a way of grouping computers within the domain security. So you have your domain, and then you can have these OUs or groups. For instance, we do this with the emergency department because there's so much traffic from the outside, patient traffic in and out. We have those particular computers all by IP address and name grouped in an OU, and so they have separate securities from other computers in the hospital because we have a group for ED that does things just a certain way in the emergency department. So where someone in their office in the hospital can have tabbed Internet Explorer browsing, the OU securities for the emergency department have turned off all the tabbed browsing because it caused issues with the application and would log users in on top of each other. And then, of course, connected. Is it wired? Is it wireless? Do you have your Bluetooth dongle in? If you're using Bluetooth, sometimes you'll need to make sure, was it actually connected? If it's a wireless device, have you got the right dongle connected, or is the dongle connected at all? the types of protocols and languages that can be used for between those areas. If you've got some secure issues going on, an HTTPS, and maybe you're looking at an address that's HTTP. So all of these things you can help with end users when you're trying to troubleshoot. And some of them are more difficult. And if you recall, I told a little story about I spent a half an hour trying to troubleshoot a software issue remoting to somebody's computer when it actually ended up being a hardware issue that I could not physically see, and that was the key on the keyboard was slightly depressed, and it was causing the computer to act all weird, and I just honestly couldn't see that doing a remote access with the person. So it's kind of trying to remember, I'll never forget that again. If I see the screen flickering or whatever, to be sure to ask the person to check the keyboard or the mouse and make sure that there's not a piece of paper or a book or it's stuck in the keyboard tray. So now that we have a mode to collect the data, we've configured our devices, even configured the output devices, so to speak. So we've set up our printers, we've set up our fax machines, we've set up our monitoring, our vital sign monitors or our OB TOCO monitors, and we've got everything configured, but now we need some place to store all this data that we are collecting. So types of storage: magnetic. These were the old magnetic tapes. If you think of just like your cassette tapes from the 80s, it's that same kind of Mylar magnetic tape. It was the most stable that we had, but obviously it can be affected by and be demagnetized if it gets near magnets and things like that. And it also required a physical person to often go in and rotate those tapes. We have optical storage, and those are your CDs and your DVDs and your Blu-rays, all forms of optical storage devices. They are more stable, but they will degrade after about 10 years, so it's not a permanent storage. Solid state is the type of storage that happens on your hard drive on your own personal computer. And solid state is the data in one location out somewhere else. So when we talk about mainframe computing and stuff, we've got basically just a super huge hard drive somewhere else that it's being stored on. And that can be the most volatile because it requires power. If you've ever lost your paper you were writing because the power went out before it got saved, that can be an issue. So where they've gone to a solid state that's more stable is the use of flash memory. So your flash drives, your SD cards, and your cameras, and in your phones, those are all forms of solid state storage that are more stable. They don't have moving parts. The data is stored there and it's permanently there for the moment in time until you're ready to retrieve it back. But it doesn't require a power source, and it doesn't have moving parts that can be damaged. Talking about moving parts, I have an external hard drive. Personal note, external hard drive, $100 back in the day. I bought it. I was so excited. And within the first couple of weeks, it had gotten bumped, and I bumped it just the right way at the wrong time. The pins touched on the hard disk inside of it, and I lost everything. So it's got moving parts, or it still has, and therefore can be damaged more easily than, say, the solid state storage of a flash card or an SD flash. Different types of servers. Most places that you have with a business or in healthcare particularly, we've got servers. We've got permanent storage, physical boxes that are working pieces, parts of a computer or like a computer's hard drive. Back in the day, it used to be the IBM mainframes. They were called a mainframe because it had a mainframe solid steel rack that then the component of the computer was plugged into, and the computers that people used in their offices were just slaves. They were just end terminals that were actually using that mainframe as the computer. Then we moved out to other servers or a SAN or storage area network, and this is a bunch of physical hard drives, for lack of a term, that share the data across them. So not one physical box is responsible for all of the data, and it can even be virtualized, and so it takes up less space. and less power in order to run the same amount of processing speeds and applications. And then we've got the cloud, and the cloud is the storage. Basically, it's the internet. It's a server in the sky. It's an area somewhere out there where you're connected up to, and you can store your data. Google Docs is a form of a file shared cloud storage. Snapfish, any place that you put your pictures, you're actually storing them out on the cloud. And all that really means is that you have access to that information at anywhere, anytime, any place, provided you can get on the internet. And we'll talk a little bit more about that later. So what is a network? A network is two or more computers or input devices that are linked to promote sharing of data and resources. If you think about your home network, if you and your friend are both sharing the same printer in your dorm room, or you and your significant other both have computers and you've got one printer between you, that's a network, as long as both devices are talking and you don't have to go and physically plug it in. Sharing of resources is sharing of the data. It's sharing of the application. So install the application once, use it many places. So why would you network? Well, we kind of just talked about that. In addition to the applications and the hardware, we've also got security controls. It allows many users' security settings to be controlled and maintained from a central location. It promotes storage management, so it spreads the data across different sectors of the SAN or different areas on these physical devices, so that if one goes bad, not all the data is lost. It's much more stable for backup and storage retrieval. Speed and load balancing. The example given in the book was, you're at Walmart and you've got one person in line, but they've got two carts that are over full of stuff. So it's going to take them a long time to get checked out. Then another line, you have three people in line, but each person only has one item. And in another line, you have two people, but their carts are half full. And so you are able to look at these three lines and assess those situations and decide which line to stand in, the one with three people with one item each, so that you can get out of Walmart faster. That's what load balancing does. It's the ability, the computer system, the server looks across and says, if I send everything to this one place, it's going to take a long time. It's really backed up. It's really busy there, so I'm going to send the information here. We've experienced a little bit of that at the hospital, where I have multiple services, multiple servers, and we'll find that when we're having some slowness issues, or the users call in and say that they're experiencing some weird things, we'll get on the computers and find out that one server didn't load balance properly and it's getting maxed out. We talked a little bit about that mainframe network, and again, it was the connection to like a big central computer, but each terminal was just a monitor terminal. It didn't have anything but power to it. It didn't have its own hard drive or own operating systems. So it was cabled directly back to this big brain in a room somewhere. Client server is the most popular and most common, most efficient, because it enables each individual computer that has its own applications and own operating systems to talk back to a server, to share documentation, documents, to share services such as telephony and communication, print services, security services, which are centrally located, and so it promotes faster access, more efficient access, and the ability to share. So similar to the mainframe, there's a centralized location, but all of those individual users have their own standalone device as well. They can be connected through cables or a local area network, which is generally a single business. So the single standalone hospital community could technically be a LAN, but then we are connected to Stevensville and Ronan and our offices that are off campus for the IT department, and that makes it a wide area network. We also have a WLAN or wireless network. So we are not, my office sits off campus from the hospital and uses radio frequencies to talk back to the hospital. So I'm technically on a WAN where the individuals that are, or a WLAN, I should say, where the individuals within the hospital themselves are on a LAN. We do have fiber optic cabling that goes the whole way to Ronan. And so that is also cable connected, but that's when it becomes a WAN. The largest WAN in existence today happens to be the internet. Then we have remote hosted. And remote hosted in a server room in the hospital, and the things that you would need to think about with the cooling and the heating and where the water pipes are, there are applications that are installed on those servers, and you're accessing them through your client. But then we have remote hosted, and our electronic medical record at Community is remote hosted. And that means that the actual servers physically reside somewhere else. And in this case, they're in a bunker in Kansas City. So Community Medical Center is not responsible for the physicalness of those servers. They're not responsible for the cooling, the heating, whether or not there's water pipes in the way. They aren't responsible for the halon system to put out a fire. We are only responsible for reporting issues that we see, that we notice. At some level, we don't even have access sometimes to some of the server configuration because it's maintained as a service agreement by the company, and that can be a good and a bad thing. It limits our access, but it also limits our liability, because if something goes wrong, if data was lost, then it's their responsibility to retrieve it, because theoretically they were the ones that would have caused it. And we'll talk a little bit now more about the cloud, because that's all the rage right now, but it is a form of remote hosting. The difference is, with a true remote host for like a business, we're paying a service contract or a service agreement that says we're going to pay you X number of dollars for X number of months or years to do X number of things for us when it comes to remote hosting. And you're responsible for updating the servers, and you're responsible for the halon, and you're responsible for the cooling and making sure that we have enough resources. So the great thing about a network is, if we need more storage, you can allocate more storage. If it's remote hosted and we need more storage, we can ask for more storage and get more storage. In a cloud environment, it's remote hosted, and there's 3 models for that. And some of it is a particular allocation of space that doesn't cost anything at all. You get so much free, so many gigabytes free. And then there's a portion where you're only paying for what you use. So instead of a flat rate service agreement like we have with a remote hosting, it's pay as you go. So if you're only using 1 megabyte, then you only get charged $1. If you're using 4 megabytes, you'll get charged $4. So it's pay as you go and as you need. It also allows you to have varying degrees of control. There's some where you don't have any control. It's updated and maintained for you. Everything is done, similar to a remote hosting, up to the level of where you can control the user, the client that is purchasing the cloud space can actually do their own operating systems and put their own applications out into the cloud. It is dynamic, and is more accessible than some of the remote hosted. That can be a good or bad thing. In the discussion questions, I asked you to look for the cloud computing versus cloud storage versus a regular server storage. How secure is the cloud? And that's the concern right now, is the accessibility is a good thing, and it can also be a security risk. So when we physically get connected to the network, we've got our devices named, we've got them either hooked up via cable or wireless, and everything's working. Now how do we get them to talk back and forth on the network now that we've got them connected? And there's an OSI model, which was a conceptual model of 7 layers of how data is packaged and sent and reorganized and repackaged and then sent again. And the highest level of that, level 7 in the OSI model, is where we get the term for health level 7 language, or HL7 protocol or language. And that's the most common health device interfacing language that we have today. And so when we talk about those devices, and when you're going to purchase devices, when it's for healthcare, whatever you use, you want to make sure it can take health level 7 or HL7. And that's just that 7th layer in the OSI model. And that's all outlined for you in the book, and you can read some more about it. We have hub switches and routers. And basically, the difference between all 3 of them is the level of intelligence that each of those devices has. The hub being the least intelligent and the router being the most intelligent. So a hub, basically, information comes in and it just distributes it. If you've ever seen a hub and a switch and a router, they all look very similar. They have their, RJ45s or whatever that will plug into the little square plug, looks like your phone jack. Maybe it's RJ11. I always get my 45s and my 11s. Maybe there's another number out there by now. You can tell I'm not a network engineer. But those little square holes that the little square cable plugs into, to keep it simple. In a hub, there might be a variety of those little holes with all the little cables plugged in. Your switch is going to look the same, and so is your router. But the hub is going to take the information in and push it back out across all of those little holes with little cables plugged in them. And it's going to receive it from everywhere, and it's going to push it out to everywhere all at once. It doesn't care where it goes. Your switch has a little bit more intelligence. It's going to take it from everywhere. It can push it out to everywhere, but it will learn. And every time that information comes in from a particular device, it can learn which device that was from and send the communication back to just that one device. So it promotes efficiency. Routers are even more intelligent and working from a similar model. It can take very specific information in. It knows exactly where it's coming from, and it can send it out to a very specific destination. So it doesn't just spam all the little square holes with all the little plugs in them. And other things to consider when you talk about your hubs, your switches, and your routers. At Community, we have switch closets or router closets. Switches are very common to be used with medical devices because they need to be able to take in the information everywhere, but oftentimes send it back to certain places. And they need to, a switch can use a MAC address, which is an address that's unique to the device. So I'll need to get back to that in just a second. So when we talk about where that switch closet's located, it's very similar to a server room. You don't want it too hot, you don't want it too cold, you don't want it under water pipes. It has to be in an area where you can easily pull your cables. The MAC address is the address of the network card that resides within a device. And when we talk about naming the computer, we can assign it a physical name. Like I said, my laptop at work is IT Carry. It's also can be assigned an IP address. That IP address can be static or it can be dynamic, a DHCP. And the difference between that and the MAC address is a MAC address comes hard-coded like a serial number to that NIC card, and you can't reprogram it. Or I'm sure there's somebody out there that can figure out how, but it's hard-coded in there. It's not meant to be able to be changed, where a computer name and IP address can change, and it can either change automatically or it can physically be changed by a network analyst. And so those are things to consider, as well as you need to know when you're setting up these networks what your device communicates with, how it connects, what types of protocols it uses to communicate, if it's got a MAC address and a NIC card. All of those kinds of things you need to take into consideration when you're actually getting the devices. So once we've got them physically communicating through a hub or a switch, again, there's some more connectivity there, but that is part of the communication. Then we have the protocols, and these protocols, the TCP/IP protocol is probably the most common, and what it is it's a group of protocols, and that includes your DNS protocols. It includes the DHCP, which I talked a little bit about being the dynamic host configuration protocol. It also contains your file transfer protocols and the domain naming system. The wireless protocols that you might need, which is the 802.11. And some of you that have been taking more computer classes will know the 802.11 history, 802.11n history. But that's your wireless protocol, some of them. The file transfer protocol, or the secure file transfer protocol, the SFTP, is the forerunner of the HTTP, HTTPS, which is another troubleshooting, right? If you're trying to get to your bank or you're trying to get to a hospital network, it has to be a secure site, and you need to have that S in your HTTP or in your FTP in order to connect securely. And if the address has been set up as such, you won't be able to get there if you don't have the S in the address name. And then there's the RDP protocols, and that comes standard with the Microsoft systems. There's lots of remote desktop protocol applications that you can use, but by default, if you're on a network, you can use the Microsoft Office RDP, and it's a set of protocols that allow one computer to connect directly to another, which is the uniqueness of the client-server network setup. We can talk client to server, client to client, and server to server, and server back to client. So it allows for a very dynamic relationship, which really promotes the sharing of information and resources. In the network basic setup, there's a lot more information and detail about routers versus wireless access points. Remember in the slides that we had from the old hospital slides I had shown in the earlier lectures, and they had that surgical room, and I talked about there's tile, there's concrete, there's lead in some of the x-ray room walls, there's old lead, and sometimes those x-ray rooms have been moved around the hospital, so you don't even know that there's lead in the walls, or concrete where you have to be able to pull wires. But those things can really affect your wireless access points, and sometimes you need extra ones, sometimes you need boosters, and sometimes wireless devices just won't work. And that's something to think about when you're putting in these devices. I talked a little bit about barcode MetaMin and having a wireless handheld scanner. There's also lab collection devices that can be wireless, and any of those could fail if they're used in an area that has doesn't have a good wireless access point, or can't because of other interference. And so those are things you need to take in consideration. Are there some areas where you need to have wired stuff versus wireless? And there's also some more information on more details on how you're going to configure with your service set identifier, SSID, how you're going to configure that wireless with your WPA security, and some other network troubleshooting. I've talked a lot at a very high level about this networking, about cloud computing, a local network versus a wide area network, installed applications versus remote applications. So I'm not going to lecture on the actual network setup. It's just a few pages, and it just highlights in a little bit more detail everything that we've talked about here. But please feel free to email me if you have any questions. So in summary, what I want you to take away from this is that there are many types of devices and configuration concerns in health IT, from ergonomics to the type of devices to wireless versus non-wireless to mobile computing versus mounted computing. Networks promote long-term storage and sharing of information in a secure, efficient, and timely manner. Recall those words, efficient and timely manner. They were part of the Institutes of Medicine's 6 initiatives. And those are essential for health IT. Networks include physical devices, they include virtual devices, and conceptual components. So that OSI model of networking is conceptual. We can virtualize our servers, and we have physical hardware that we need to consider and physical wiring when we're talking about setting up our network. It uses cables and wireless technology along with protocols to connect and communicate across that network. And there's a huge variety of ways that you can configure a network based on your needs, the domain needs, the security needs, and then you can configure it at all kinds of different levels. It's fascinating, and I can always get you in touch with somebody if you'd like to talk more about network engineering.